Hello, this is FlippedHarber for Precalculus. In this video we'll cover section 7.1, Solving Right Triangles. Our objectives for this lesson are to solve right triangles and solve applied problems. That's just a fancy word for story problems. Our outline for this video will look at solving right triangles. We'll take a look at some simple reminders. We'll look at solving a right triangle where one side and one angle is given. And we'll solve a right triangle where two sides are given. And then we'll end with an application, a story problem. Now, when we say solve a right triangle, or really solve a triangle of any type, it simply means that you need to find any missing side lengths and any missing angle measures. So they'll tell you, maybe two of the sides of the triangle and an angle, and you need to find the missing angle and the missing side. Okay, simple enough. Whatever we don't know, we need to know. So let's take a look at some simple reminders. Now these are exclusive to right triangles. Okay, this whole section is about right triangles, so you get to use these. Something to remember, Pythagorean's theorem. A squared plus b squared equals c squared. Don't forget that. We can use that to solve for a or b. We don't only get to use it to solve for c. And remember that since it's a right triangle, one of those angles, is known, that means that the other two angles have to add up to 90 degrees. Okay, just some couple quick reminders to get you through this section. Alright, so let's take a look at solving a right triangle where one side and one angle are known. Now this is kind of actually misleading because we actually know two angles. Since it's a right triangle, you know that one of the angles has to be 90 degrees. So that might be your first thing to find, is that missing angle. I really don't care what order you find them, just as long as you find everything you're supposed to find. So if b equals 5 and alpha equals 40 degrees, then we want to find a, c, and beta. Now our naming convention for this is a and b are the two legs of the right triangle and c is the hypotenuse. Okay, not a big deal there. You're very used to that. Our naming convention further says that alpha, that weird fish-looking Greek letter thing, is the angle opposite A. Beta is the angle opposite B. So even if they don't give you a picture like this, you need to stick with those conventions so that you actually find the angles and the sides in the proper order. Okay, so let's see where we're going to start. Let's go ahead and find beta. Hey, beta has to be equal to 90 degrees minus 40 degrees. Well, that's easy. Beta is equal to 50 degrees. Well, where are we going to go from here? Well, I can't use Pythagorean's theorem because Pythagorean's theorem I need to know two sides to get the third. Oh yeah, that's right. This is a section, a chapter about trigonometry, so let's use some trig here. A has to be equal to 5 times the tangent of 40 degrees. Now where did I get that? Well, the tangent of 40 degrees has to be equal to the opposite side divided by the adjacent side. So I'm going to use that fact. So I can find A by taking 5 times tangent 40 degrees. Plug that into my calculator, I get 4.19. Okay, so that leaves one thing left to find, and that would be the hypotenuse C. Well, let's go ahead and use good old Pythagorean theorem. C is equal to the square root of 5 squared plus 4.19 squared. Once we plug that into our calculator, we get 6.52. And we're done. Okay, so let's take a look at one where the two sides are given. Well, maybe the first thing to find would be C. It's equal to 5.39. Easy enough using Pythagorean's theorem. What about those two angles, alpha and beta? Well, I'm going to use some trig to find one of them. Doesn't really matter which one I find first. So let's find alpha. It's equal to a tangent inverse. Remember, inverse tangents, inverse sines, inverse cosines, they give us angles. So alpha is equal to the tangent inverse of 5 over 2, opposite over adjacent, and we get 68.2. Well, I don't need to work this hard to find beta. I'll just go 90 minus 68.2 in order to find beta, 21.8 degrees. Now when you're doing this in homework or when you're doing this on a test, please make sure that everything is very neatly labeled. Make sure that I can see that C equals 5.39, alpha equals 68.2, and beta equals 21.8. Okay, let's go ahead and take a look at an application. Okay, to measure the height of a building, two sightings are taken a distance of 50 feet apart. If the first elevation is 40 degrees and the second is 32 degrees, what is the height of the building? Now notice, they didn't measure how far away from the building they were. They measured how far apart their elevation measurements were. Why? Well, sometimes it's easier to do this, and we're going to see an example in your homework where you can't really do the distance out, okay, because it's not going to be a straight structure. It's actually going to be the height of one of the pyramids in Egypt. So how are we going to approach this? We have this 50 feet that's between our two angles. We don't know h, that's what we're looking for. We don't know x. Well, how about we find h in terms of x by taking two tangents. The tangent of 40 degrees has to be equal to h over x. The tangent of 32 degrees has to be h over x plus 50. Now that we have two equations with our two unknowns, h and x, we can solve for these. Now, all I really care about is h. I don't actually care what x is. If I accidentally find x somewhere along the way, I just plug it in and I find h. No big deal. But if I go ahead and solve for x in both of these equations and then set them equal to each other, I can actually find h without ever knowing what x is. So solve for x in the first equation, solve for x in the second equation, and set them equal to each other. Now it's just a little bit of algebra in order to solve for that h. The first thing I'll do is move some things around so that I've got the h's on the same side. So here you see h over tangent of 32 minus h over 40, and it's equal to 50. So you could think of this as this stays, this gets subtracted over, and this gets added over. Now that I've got the h's on the same side, I'll factor the h out, and I'll divide by the stuff that was on the left side with the h. Now, I always like to wait until the very end to plug everything into your calculator. If you want to plug stuff into your calculator ahead of time, that's fine. Okay, go ahead, plug the tangent of 32 degrees in, plug the tangent of 40 degrees in. Oh, I just realized, got a typo right here. That should read the tangent of 40, not just a plain old 40, the tangent of 40 right here. You see that down here, tangent of 40. So you plug this all into your calculator, 122.4 feet. Never actually found out what this was. Okay, that's kind of handy. Okay, so this isn't that bad of a section really. Try it on your own. I'll see you in class. I'll see you online.